All right, so we'll go ahead and finish up the section 7.3, trig substitution. I've got just two more examples here left to show you. Suppose that we want to integrate the square root of a squared plus x squared dx, where a is some number. Okay. I'll comment on the star there later, but x would be equal to a times tangent theta, right? That's going to be that guy right there. And dx is a times secant squared theta d theta. Okay, if x is equal to a tan theta and you divide both sides by a, tan theta is equal to x over a. Tangent theta is opposite over adjacent, so the opposite side would be x, the adjacent side is a. And the leftover hypotenuse of the triangle would be the expression that led us to the trig substitution there to begin with. The square root of a squared plus x squared is, well, x is a tan theta, right? So if I replace x with a tan theta there, and I square that, and then factor out an a squared, I've got a squared times 1 plus tangent squared theta. 1 plus tangent squared theta, that's secant squared theta. And if I take the square root of both sides of each term here, the square root of a squared is a, the square root of secant squared theta is secant theta. Okay, so I have a secant theta. Remember that you always need these three things here whenever you make a trig substitution to place in the new integral. Okay, also build the triangle too. That's key. So let's see, the square root of a squared plus x squared, well, the square root of a squared plus x squared, that's a secant theta. Dx is a secant squared theta d theta. Okay, so then a times a, that's a squared, that can factor that out of the integral. Secant theta times secant squared theta, secant cubed theta d theta. And now we have seen this integral before. Okay, we saw that in section 7.2 right here, right? So I'm going to integrate this same integral here. And we need to use integration by parts. So if I let u be secant theta and dv be secant squared theta d theta, du is secant theta, tangent theta, d theta, and v is tan theta, derivative of tan theta is secant squared theta d theta. Okay, I would not have these flipped. Okay, because if u is secant squared theta and dv is secant theta, well, du would be 2 secant theta times tangent theta d theta, and v is the ln of the absolute value of secant theta plus tangent theta. Now, if I multiply those two things together there, that does not sound like a fun integral to be working with. That makes the integral more complicated than what it was originally. Okay, and remember that with integration by parts, you're creating a new integral where the new integral is going to be easier than what it was before. Okay, so again, keep that in mind. So using integration by parts, we got u times v is secant theta times tangent theta minus the integral for v du, the integral for secant theta times tangent squared theta d theta. Tangent squared theta, that is secant squared theta minus 1. So I'm replacing secant squared theta minus 1 with in the tangent squared theta spot there. And then if I break apart this this integral here into two integrals, I've got a squared times secant squared theta, a squared times secant theta times tangent theta minus secant squared theta, and then plus, negative times negative is positive, the integral for secant theta d theta. Okay, the antiderivative of secant theta is, again, the ln of the absolute value of secant theta plus tangent theta. So the next thing I'm going to do is I'm going to add this integral to both sides here. Okay, And I've got 2 of these integrals then on the left, okay? And that's equal to the leftover then on the right would be a squared times secant theta tangent theta plus the ln of the absolute value of secant theta plus tangent theta, and then plus a constant. If I divide both sides by 2a squared, then if I divide both sides by 2, then this integral here, a squared times the integral for secant cubed theta d theta, is a squared over 2 times the quantity secant theta tangent theta plus the ln of the absolute value of secant theta plus tangent theta plus a constant. Okay, and so then now this original integral here, which is the square root of a squared plus x squared, so that became the integral for a squared times the integral for secant cubed theta d theta. Well, I know what that integral is now. Okay, it's this guy right here. So basically, I've got this quantity here. Now the last thing I'm going to do is, because my final answer has to be involving x, the original integral was involving x, I'm going to refer back to the triangle, which is in terms of theta here. Secant theta is hypotenuse over opposite. Okay, so excuse me, the hypotenuse over the adjacent side. So I've got hypotenuse is the square root of secant of the square root of a squared plus x squared, and the adjacent side is a, times tangent theta, that's opposite over adjacent. The opposite side is x, the adjacent side is a, plus the ln of secant theta plus tangent theta. Well, secant theta is, again, hypotenuse over the adjacent side, okay? And then plus tangent theta is opposite over adjacent, okay? Plus the constant. So then when I distribute a squared divided by 2 into these parts here, the a squares will cancel out on the first part there. And I've got x times the square root of a squared plus x squared divided by 2 plus a squared over 2 times the ln of the absolute value of the square root of a squared plus x squared divided by a plus x over a plus a constant. Okay, and again, I'm calling this C1 just because I'm dividing both sides by 2. So C1 divided by 2 would actually be the constant. C1 divided by 2 is just some other constant, so I'm calling that C. Okay. Now, just as a note here, this is important, and this is why I have that star there. The last integral is going to be needed in a few of the homework problems in future chapters. So specifically 8.1 and 8.2. You'll need to know this integral because, I mean, I wouldn't want to do this integral all over again. Okay, if I already know the answer, just refer to the answer. And so, make a note of this for when you get into, chapter 8, 8.1 and 8.2, this integral will come up. Okay, so whenever we have this integral, you can just refer back to what we did here in section 7.3, and here's the answer. Okay, and I can just go to the answer and fill that in and continue with the problem that I'm working on in 8.1 or 8.2. Okay. I got one more example here. So suppose that we want to integrate 1 divided by x times the square root of 16 minus 9x squared. Okay. Now, you can use the u substitution to begin. So if I let u be 3x, 3 squared is 9. Du is 3 dx. So then divide both sides by 3. You got a 1/3 coming out of the new integral there. And you're going to have 1/3 times the integral for du divided by x is 1/3 u, right? And then times the square root of 16 minus u is 3x, so 3 squared is 9, right? So you got 9x squared there. So the square root of 16 minus u squared. Okay, these 1/3 will cancel. So then this is the integral that I need to find. Okay, well, if I use a trig substitution there, my a value is 4. 4 squared is 16. Okay, so 3x is u, okay, but u would be 4 times sine theta. U is 3x again. So 3x equals 4 sine theta. If we divide both sides by 3 to get x all alone, x would be 4/3 sine theta. Okay? You know, I can build my triangle here. If I divide both sides by 4, 3x over 4 equals sine theta. Okay, well, here's theta. Opposite side would be 3x. The hypotenuse is 4. And the leftover adjacent side would be the expression that led us to the trig substitution here. By the way, that should be a squared term right there. So then the next thing here is, well, dx is 4/3 cosine theta d theta. Okay? The square root of 16 minus 9x squared, well, that's going to be the square root of 16 minus 9x is 4/3 sine theta. Okay, so I'm squaring that. 9 over 3 squared is 9. Those are gone. And I got 16 minus 16 sine squared theta underneath the radical. You can factor out a 16. 1 minus sine squared theta, that's cosine squared theta. Okay, and the square root of 16 is 4. The square root of cosine squared theta would be cosine theta. Okay, and I think we're ready to fill in the new integral there involving theta. So let's see, dx, that is 4/3 cosine theta d theta. X is 4/3 sine theta. And the square root of 16 minus 9x squared, that's 4 cosine theta. Okay? These 4/3 cancel. And these cosine theta terms will cancel. So I got 1/4 times the integral for 1 over sine theta d theta. 1 over sine theta is by definition cosecant theta d theta. Okay, so that's the function that we want to integrate. Now, to integrate that guy, you're going to need a sneaky little trick very similar to what we did here when we integrated secant theta. Okay, this isn't something that I expect you to see. So I just tell you what you're going to do. But you're going to multiply the top and the bottom of cosecant theta divided by 1 by cosecant theta minus cotangent theta. Okay, and if you distribute the cosecant theta terms, you got cosecant squared theta minus cosecant theta cotangent theta divided by cosecant theta minus cotangent theta. There's a 1/4 out of the integral. Now, the reason why we did that is because that allows us to make a u substitution. If we let u be the denominator here, cosecant theta minus cotangent theta, du is the derivative of cosecant theta is negative cosecant theta cotangent theta minus the derivative of cotangent theta is negative cosecant squared theta d theta. Okay, well, negative cosecant theta cotangent theta plus cosecant squared theta d theta, that's exactly what I have in the numerator. Okay, so this substitution is going to work, and I end up getting 1/4 times the integral for 1 over u du, which is 1/4 times the ln of the absolute value of u plus c. Don't forget about the absolute value bars. U is cosecant theta plus cotangent theta. Okay, and the last thing that I would do here is I need to get my answer in terms of x, right? Because the original integral was involving x. So refer back to this triangle here. And again, by the way, you know, whenever I integrate any problem involving a trig substitution, I am always doing 3 things ahead of time. I'm finding what x is, dx is, the square root expression, and I'm building the triangle. That is essential for getting the answer. You need all 4 of those things to get the answer. Okay? Let's see. Cosecant theta is the reciprocal of sine theta. Sine theta is opposite over hypotenuse. So we're going to want the hypotenuse over the opposite side. 4 divided by 3x. Minus cotangent theta is the adjacent side over the opposite side, okay? Because cotangent theta is the reciprocal of tangent theta. You know, I guess if you wanted to, you can get a single fraction in here. You don't need to do that, though, if you don't want to. But my answer is going to be 1/4 times the ln of the absolute value of 4 over 3x minus the square root of 16 minus 9x squared over 3x plus c. Okay. Now, again, knowing trig substitutions is very important. So I think, you know, all but one of the problems in this section should be trig substitutions, you know, but don't always go to trig substitutions, right? So the first thing that I'm always looking for is if I can get the answer just by using a simple u substitution, okay? So anyway, the homework problems are on page 505 there. Be sure to have a go at those.